Okay, thank you and welcome to today's webinar related to IEA-EBC Annex 78, substituting ventilation by gas phase air cleaning, an industry webinar. We have several speakers today, and we all have two sessions with questions. My name is Bjarne Olesen, and I'm a professor at DTU. I will start talking about the concept for substituting ventilation by gas phase air cleaning. So let me start by just introduce you to this EBC IEA. That's EBC is Energy in Building and Communities, and it's a technical project under the International Energy Agency. The operating agents is here from university, Pavel and I, and we will both be speaking today. Right now, the annex is in the working phase, which ends summer next year, and then we have another year for reporting. But there will not be, there's no strict ending of the work phase. We will still be doing some working also on the reporting phase, and we are starting the reporting now. The annex has four subtasks. One is related to energy benefits using gas phase air cleaning, led by Alireza Afshari, who also have a presentation today, not on the energy, but on technologies. Then we have a subtask B on how to partly substitute ventilation by air cleaning, led by Pavel, who will be speaking today also. And we have one on selection and testing standards for air cleaners. We will have presentations here today, and this is led by Paolo. And last, we have one on performance modeling, a long-term field validation of gas phase air cleaning technologies. We have members from 8 different countries who participate actively in this annex. The deliverables which will be received, they're coming out from beginning of next year and then over the next 1.5 years. We will have a method for predicting energy performance of gas phase air cleaning technologies. We will have a procedure for supplementing, that's what we are talking about today also, required ventilation rate with gas phase air cleaning. And we will have a report on a test method for air cleaning technologies that, beside chemical measurements, include perceived air quality. And that's the focus of today, to see how you can do testing by using also perceived air quality as a measure of performance. And then finally, some report on long-term performance, models for predicting performance, and then related to the first talk today, a presentation on existing gas phase air cleaning technologies. We are presenting the technologies, not that it's an endorsement of technologies, but just what is available today. So the concept for calculating the design ventilation rate, both in ISO CEN and ASHRAE standard, is that we basically talk about two sources of pollutants. That people, we always have people, that's why we ventilate. So people have emissions, bioeffluents, so we need to know how many people, and we have pretty good indication on how much we need to ventilate per person. And then we have a contribution from emission from the building, furnitures, interior decorations, and even from the system itself. And we have here tables in standards which give a number of liters per second per square meter for building area. So what we are going to look at, is it possible to reduce this required ventilation rate by use of gas phase air cleaner. We also have another method using a mass balance of different substances, where for the general ventilation, we often use CO2 as a reference for how much to ventilate per person. That's also one way of calculating required ventilation rate. So what we are looking for when we supplement ventilation by gas phase air cleaning, that is something we call the clean air delivery rate. If we can measure the clean air delivery rate of an air cleaner, we can reduce, let's say, the required ventilation rate with this number. And we will see there are some testing standards today based on a chemical measurement before and after an air cleaner, with which you can get an efficiency related to the cleaning efficiency based on a chemical measurement at a gas concentration. The other what we are talking about today is we can also measure how efficient it is to reduce the perceived air quality. And we will talk more about that, and that's also a way of getting the clean air delivery rate. So there is already a publication from AIVC, a ventilation information paper, or VIP number 42, which can be found on the AIVC website, where we talk about the concept for substituting ventilation by gas phase air cleaning. And the reason why we have started looking at testing of air cleaners, you will see there are some existing standards, but we don't think they're always sufficient. And that is some test we did years ago on an air cleaner. And we see here a test where the sources for the pollutants are building materials or used filters. And we measured how people felt. So we were using people as our measuring instrument, how people, a panel, how good they found the air quality. The higher number on this scale here is the worst it was. And if you look the blue and the orange, you see with the air purifier on, that's the orange, we found a better air quality, lower number. And when we increased the ventilation rate from 35 to 59 liters per second in that room, we saw the effect of increasing ventilation was about the same as the effect of the air cleaner. So we could say, here give what the effect would be of the air cleaner. But when we now used human bioeffluents as a source, and that's what we always have in rooms we ventilate for people, we saw the opposite. Then when we turned on the air cleaner, the perceived air quality got worse. And that made us looking for that we have to be careful when we evaluate the effect of air cleaners, and we think they improve the indoor air quality, that we have the right testing. So here's an example of a previous testing where the upper curve, where we measured the percentage of dissatisfied, and from this number we can go up to the perceived air quality for different levels of ventilation. And that was, the blue one was without air cleaner, and below you can see a curve that's with air cleaner. Normally we design for 20% dissatisfied, and we can see at this level the difference, and this is the clean air delivery rate, was in the order of 2.5–3 liters per second per person. And that means that's how much we then could reduce the amount of air to get the same air quality. And this is that kind of information we want to establish with a test. So what we have established is a concept for substituting part of the required ventilation with gas phase air cleaning technology, and I have briefly presented it here. But we see there is a need for new testing standards that considers perceived air quality and human emission as the source. And that is what we are going to show you and discuss in the following presentation.